Hello everyone. In this video we will do two more examples in which we need to combine different integration techniques, including the partial fraction decomposition. So let us start with the first one, integral of ln of x squared minus 4 dx. Remember that most of the times when we had just ln in the integral, the technique that worked for us was integration by parts. So I will go with the same idea, but let's see what will come out of that. So here I will say that, okay, u is ln, that's what usually we take. And then dv, well, there is nothing left, just dx itself. Then from there we see that du is going to be, remember, derivative of ln of a function would be the derivative of that function. Here would be 2x over that function itself. And integral v is given by integral of dv, which is just integral of dx, and that will give me just x. So this way my integral u dv is equal to v u, so it will give me x ln of x squared minus 4 minus integral of v du, which will be 2x, this is du, times x, which is v dx. So the first part is done. Now we have to go and try to see what we can do with this part here. And as you can see, this is a rational function, but the degree of the numerator and denominator are the same. So we have to do long division first. So let me write it here. So we have 2x squared, we want to divide it by x squared minus 4, and well, 2 will do the job, so 2 times that is 2x squared minus 8. We subtract that, this will cancel these two out, and then there will be 8 down there. So this is s, this is the remainder, so we have 2x squared over x squared minus 4 is equal to 2, then plus 8 over q, which is x squared minus 4. So that way we can reduce the integral to this one here. But we notice, okay, the first part is just nothing. The second part, however, we note that, okay, this we need to do the decomposition. So I will start with 1 over x squared minus 4. That will give us, well, the factorization of x squared minus 4 is x plus 4, x plus 2, x minus 2, yes? So I will have x plus 2, x minus 2. These are going to be our partial fractions. There will be their numerators there. So combine these things, this will give us a x minus 2 plus b x plus 2, and then this will be x plus 2 x minus 2. And from there you see that x, the numerator left hand side, must be equal to numerator of the right hand side, which is a plus b times x, and we have 2b minus 2a. So the coefficient of x on the right hand side is a plus b. On the left hand side there's no x, that means the coefficient is 0. The constant term on the right hand side is 2b minus 2a. On the left hand side it's just 1. So from the first one, we see that a must be negative of b, and then combine these two, we see that we get 2b plus 2b must be equal to 1, and that tells me that b is 1 over 4. And then, okay, you see that b is 1 over 4, and we know that a is negative of b, so that means that a must be negative 1 over 4. Okay, the decomposition is there, so we have 1 over, a is negative 1 over 4, and b is 1 over 4. So I'm just using this decomposition the way we set it up. But there's that 8 outside, so we can factor out those 1 over 4s. And what we'll get here is that 2 times integral of negative 1 over x plus 2 plus 1 over x minus 2 dx. And that is 2x plus 2 times ln, okay, there's a minus sign here, ln of x plus 2, and plus ln of x minus 2. Well, we can simplify this. 2x, yeah, plus ln of, using the properties of log. Then I put this 2 inside, so that will make everything nice for us, meaning that we won't need to have absolute value there. So you will get ln of x minus 2 over x plus 2 squared and plus c. So that was just that one part of the integral we had. If we go back now, we can plug it in back into our integration by parts, and the final result of this integral is going to be x ln of x squared minus 4 minus 2x plus ln of x plus 2 over x minus 2 squared, then plus c. Okay, so we did integration by parts, and then turned out that we have one of these rational functions, and we went from there. Let's do another example here. Okay, so it is a very strange integral there, but one thing that may help you to see what to do is that you see that the denominator is in terms of tan. So I have tan t squared plus 4 times tan t plus 4. In the numerator, yes, we have 1 tan t, but the important thing is that the derivative of tan, which is secant squared, is also there. And right away, seeing derivative of tan as the coefficient or multiple of the integrand in the numerator, that means that you should try u substitution, hoping that it will solve the problem. So we set u to be tan t, then du is going to be secant squared t, and this way our integral is going to be, you see, this part secant squared t dt is going to be du, but then the rest of that can be written in terms of u. Yes, so my integral is going to be u over u squared plus 4u plus 4 du. This is nice. This is a rational function with the degree of the numerator less than degree of the denominator. Well, we have to go ahead and see, can we make it into, or find the partial fraction decomposition for this one. So we start with the denominator, u squared plus 4x plus 4, and we try to factor it, but we notice that, oh, look, this is this guy. So we have a linear factor to the power 2. That's the factorization of the denominator. So that means that if you want to set up the decomposition, repeated roots tells me that we should put u plus 2 to the power 2, and must be, all these things must be that partial fraction. So this will be a, this will be b. Okay, so then we can go ahead and then simplify this. I multiply u squared plus 4u plus 4 there, plus b times u plus 2, and oh no, I'm not doing good there here, sorry. The common denominator here, I'm going to put u plus 2 squared. So what we will get here, u plus 2 plus b. B won't have any new factor. So this means that left hand side, the numerator left hand side, which is u, must be equal to the numerator of the right hand side, which is au plus 2a plus b. And well, this is two polynomials are equal if the right hand, the corresponding coefficients are the same. Here, the left hand side, the coefficient of u is 1, and the right hand side is a. The constant on the left hand side is 0, on the right hand side is this guy. Well, that gives me what is a, and this gives me what is b. So meaning that we found the integral that we were looking for. A is going to be 1 here, sorry, the decomposition that we wanted to work with. So this will be integral of 1 over u plus 2 du minus 2 integral of 1 over u plus 2 squared du. These are partial fractions with the linear powers of linear in the denominator, and you know that how to work with these ones. For the first one, this is just straightforward. For the second one, you can set u plus 2 as your new variable, and then you always do substitution with these partial fractions of this form, yes. But if you complete that, it will give you just u 1 over u plus 2, there's coefficient 2 there, and there's a negative sign as well. So this does the job for us. But we are not done, because we have to remember to plug in back our original variable. So this will be tan t plus 2 ln of that plus 2 over tan of t plus 2, then plus c. So one substitution, we turned it into a rational function, and then from the rational function we know how to deal with the integral of rational functions.